line is, and it's not even something that's going to be documented. Yeah, that's just so stupid. Like, so literally, the code I had before, which was this, without this one line of setup attachment root component, which you would assume is what happens. Like, when you create a default subobject, it gets attached to the root component of the object, which is where the object is. But no, that's not what happens, because, like, obviously that's not what you wanted. That's just insane. It's so stupid. So basically means, like, is there some overload of create default subobject which takes a component? No, none of them do. So, like, literally, there's no way to shortcut this. For every single component that you create, you have to attach it to your root component, or it's going to get, shot off into frickin' space. So every single time you do something like this, you got to write 2 lines of code. And if you forget that setup attachment, then your position is going to be, some insane value that you don't understand. So the question is, did I already do this inside of the entity utils? Doesn't look like it. Of course, setup attachment, I guess, only works for scene components. So it's something like, if you have a scene component, you have to set up the attachment of it. What a raft. And let's make sure I have a comment here. Alright, so now that that's set, what we're going to need to do is rotate our object and all that. Just make sure putting a comment here didn't change the transform. Alright, so what we need to do is we need to now work on the movement. So move an object needs to rotate the flipper component, which now should be detached from the thing. So let's see if this crappy rotation code we wrote yesterday, it should rotate the flip book, but it shouldn't change the collision or anything like that. And this is kind of what we'd expect, is that since it's no longer the root component, we're not screwing stuff up with that one, the roll 90 degrees thing here. So like this should be a 0. So yeah, it looks like it's not the worst thing ever. So we're going to need the actual rotation. The question should be, how should we achieve fetching the normal for the surface? So we're guaranteed the last call is going to be the snap to ground, pretty much. So the snap to ground, I guess, maybe should grab our surface normal. Alright. Man, I'm just distracted today. Alright, so maybe I'll actually get focused here again. Alright. Let's get back on track. Sorry, people in chat are arguing about or talking about Uber and how they're just a shitty company and how, I mean, what a culture of law breaking, basically. How do you fix a company when there's obviously a problem with the industry that, you know, somebody ignoring certain regulations is so successful literally because they ignore those regulations versus, you know, the systemic horrible things that have been going on to employees. Alright. I don't know enough about about any of that to have a very well-founded opinion, but I can have an unfounded opinion. I can have a stupid opinion. And I can stand behind it relentlessly. Alright, so we're going to want an F vector normal. So let's see if we've got anything like that already. Doesn't look like it. Airbnb is pretty much the same. Yeah, there's a lot of side effects with that whole thing. F vector M class normal. So let's set it to, I guess we should set it to the opposite of down. I mean, it's one of those things, right? Like, when we went down to my brother's wedding, we used Airbnb, and I've used Airbnb before and stuff like that, but it's still just like an illegal hotel, pretty much. But at the same time, it's also, you know, like, the people you meet are pretty cool, and it's kind of like, why is that illegal? But then again, it's a lot easier and a lot safer if you're a dude, because you're like, I'm gonna go stay at some unverified place with some random skeezy person. And it's like, oh well, you know, I'm just there with a couple of my friends or whatever, and you know, as a man, it's a lot easier to just accept that risk because our culture and everyone's culture, it's just weird, isn't it? All right, so we're gonna want a get last normal function right here, and we're going to return an F vector for that. I guess maybe we should do a const F vector reference. Maybe that'll be all we need. But then you've got like tons of people who, like, that's the only way they can make it. Like, I know some people in Seattle or San Francisco, like, the only way they can even afford rent is, you know, they Airbnb out their place and stuff like that, and then everybody's doing it, and it raises the cost of housing. And you're just like, well, Jesus Christ, like, what are you supposed to do about all that, right? So it's one of those. I don't know. We had this. It just reminds me, we had a debate in just social studies in high school. You know, one of the things, I guess, in the American education system, social studies classes will have you talk a lot about stuff. And just pose questions, or at least that class did. It wasn't like a history class or something. And it was about file sharing, and this was the high school teacher saying like, "What do you guys think about file sharing and all that?" And of course, everybody's like, "Oh yeah, piracy and file sharing is the best and should be legal, and copyrights are stupid." And it was just really funny because this teacher's like, "You're all arguing just to break the law." He's like, "Yeah, but it's damned inconvenient." It's like it's against the law though. Like you guys should be like, you're arguing that you should be able to break the law. It's really funny. And it's kind of one of those things, like, I don't know, at some point there, it's like, well, the law needs to be changed if it's going to be used in a certain way. All right, so we're going to want in our update our tick movement. So tick movement should basically so we're going to set this to negative down. Basically, if we're flying, our last normal is negative down and all that stuff. I guess maybe I should set our last normal at whenever we tick our physics. Or I'm trying to think about what the best plan is. Alright, update locomotion loco. We need update on the ground, and we need locomotion in the air. Alright, so if we're on the ground, our last normal is going to be... Do we have any returns right here? Yeah, we have 2 returns for being in the air. We have a return after we snap to the floor here. And everywhere else we're snapping to the floor. So we should do this update snap to floor stuff. Alright, so if we're in the air, again, we'll set ourselves to negative down, and all that. So the question is, which normal should we be getting? And I guess the normal here, where we do our sweep down. Alright, so the angle is going to be this get angle from vector, I believe. And I wrote that in our math utils. So in SX, SY, EX, and EY. So that's going to be Y and then Z. So the angle is going to be that. So our rotation is basically going to be, this is the angle, but the angle assumes that it starts at 0. So if we rotate, and this is relative to me, so my right, rotate 90, so it should be, we subtract 90. I'm pretty sure this get angle from vector is returning a tan 2. I think it's radian 2 degrees. Well, let's see what it is. See if it works. I don't know, it's kind of also arguing about all those different things. I think also comes back to, you know, the philosophy question of like, are humans necessarily inherently evil or not? Because it's right there in black and white. If things are inconvenient, people don't give two shits about the law. So let's see, what was the set direction auto stuff? Set wanted velocity in vector, so set direction auto. Set direction by velocity. Set direction by y. Set direction. Auto change transform for direction is false. Alright, so what I need to do is I need to get the current rotator. Alright, so we'll get our vector transform, and do we have like transform that get rotation? dot get rotator. Is there like rotator? Yeah, there's rotator dot. It's one of these values. So what's the F rotator got? Its constructor is pitch yaw roll. So I think it's yaw. So look at the. Right, so basically what we're going to say is the angle is either negative 90 or 90. Negative 90 is left. So if yaw is less than 0, then angle equals negative angle. So we're going to base ourselves off of our actor transform, not off of our direction or some other shenaniganry. Alright. So let's see, we should now be able to... That turning around animation was messed up. It was off by, it was flipped. And there is definitely a one frame glitch. So why is that? It's basically our... when our rotation gets fixed, we need to update all the things, is what it seems like. So, what is the... What's going to be the reason for this? And this is probably what was going on before. It's just now a lot more obvious what's going on. Not what's going on, but that there's a problem. So it's inside of the post update. Let's crack open the editor and take a look. Alright, so I believe that's inside of our crouch state. We've got some logic there that directions. Set transform to specific direction. So let's see what this set transform to specific direction actually does. So let's run this. And we call set transform to specific direction. And this is inside of tick flipbook on animation end callback. So this is inside of the animation end, which may call at the wrong time. Like, this animation stuff is going to play after everything is done, so we need to like set the normal again down here. Basically what we want to do is we want to get the actor transform right here. I'm trying to think. I can see if we were actually flipped right here, but yeah, so get the rotator for the current transform. Compare the yaw angle to see if it's different. If it isn't different, return. Grab the angle from the flipbook rotator. Grab the yaw from the flipbook rotator and invert the yaw and set it. Alright, so here we go. So we need to get transform.rotator .yaw. So we're going to say if fmath absolute value of the yaw equals angle, then we're going to return. So if we are flipping, then we want to flip the angle that we're at. The reason we're not just going to call like set towards rotation is because we want to take delta t into account, and in our flipping we don't want any flips to do anything crazy. So we want to grab m flipbook F transform flipbook transform equals get relative rotation dot what rotator dot yaw. So I guess we should get an F rotator flip rotator and say flip rotator dot yaw times equals -1 and flipbook set relative rotation, and we'll just pass in the flip rotator. Let's see if it does what it's supposed to. So let's see what it looks like. Ah, it's not yaw, it's pitch. So we're trying to basically snap our guy to the ground, rotate him so that he is properly normal to that ground, and then we want to see what it looks like while we're moving around, and see if it looks real stupid. Yeah, and that's one of the things right there. Because of mathematical imprecision, you're like, well, where's the normal? So I guess for this normal, we need a little bit more. I mean, it doesn't look too awful. It's really just at that edge, like, we could smooth it out. I guess maybe I just have to recalculate that normal. So why don't we just try it? Hmm. So but this is the pitch movement fix speed. .90 degrees per second. Well, we're gonna need this pitch fix speed. So set direction and all that stuff, on direction change and all that. Set transform to direction, set transform to specific direction. So this will always fix our pitch properly based on a directional change. So this right here, we basically want to have, like, this is the wanted angle. So we're going to want to get the We're going to want to get the pitch right here. So it should be, if yaw is less than 0, angle equals negative angle. Alright, so we've got the float per angle equals this flip rotator.pitch. And we want to do our lerp stuff towards it. So it's going to be starting at current angle, ending at angle. The t is this g movement fixed speed, and I mean the t is delta t. And that should be our angle. So angle equals this. Setting rotation to that. So I'll have actual angle, setting rotation to that, while current is %f and wanted is %f. So I'll have actual angle, current is current angle, and then wanted is just angle. Alright, let's see if it works. We should smoothly transition between angles based on just a linearly interpolating value. We'll see if it works. We should, this is not going to account for those swapping normals every frame and all that stuff. I'm going to have to think a little bit more on that. I think we're really going to want to take like our movement vector direction or something like that. But that changes every component. I mean, that's also changing every single frame there. It's like, which surface were we actually on? Well, we were on either surface very, very quickly. It's basically like we've got these two platforms here, and the issue is we're standing right on top of both of them, and the impact normal is swapping from this normal and this normal. So I mean, what we could do is basically have a ray trace on our right extent and our left extent going straight down and see like what the distances are, and if the distances are close enough, then the normal is going to be what the average of those two, or if the distances are close enough from those two ray traces that we don't have a normal. It's just like, nah, it's pointed straight up. There are some other options. That's not a terrible option, to be honest. Interesting, it actually handles the flipping quite well with a slow change. Interesting, it flipped it. Setting rotation to 34. Alright, so we want if the transform, the map absolute value of this angle, pitch, yaw, roll, we want it less than tiny float. Alright, this is going to be flipping, transform, and graphics, transform, pitch. Let's try it. So we might not have to solve this if we can just find a good balance. Alright, so what we're going to do is update rotation. If get physics state is on the ground, then alright, we'll have a boolean here. We'll have bool snap equals false. Actually, we're going to say snap equals true. So snap is going to be false if we're on the ground. So if we are in the air, it's just going to be like, boom, just set it to 0, we're done. So snap was true. Okay, now the next thing is, we want this to be quite a bit faster for the change. But I don't want it to be super fast. I basically want it to be like, we want it to be really damn fast. So this is 90 degrees per second. What if we just upped it